Boyles Law, volume versus pressure. I'm Mr. B. Boyle's law is a relation concerning the compression and expansion of a gas at constant temperature. It states that the pressure, P, of a given quantity of gas varies inversely with its volume, V, at constant temperature. In equation form, we write PV is equal to K, where K is a constant. The law can be derived from the kinetic theory of gases assuming a perfect or ideal gas. Mathematically, Boyle's law can be stated as P is inversely proportional to 1 over V. Or we may simply write P times V is equal to K, where P is the pressure of the gas, V is the volume of the gas, and K is a constant. The equation states that the product of pressure and volume is a constant for a given mass of confined gas, and this holds as long as the temperature is also constant. The equation shows that as the volume increases, the pressure of the gas decreases in proportion. Similarly, as the volume decreases, the pressure of the gas must increase. For comparing the same substance under different sets of conditions, the law can be usefully expressed as P1 V1 is equal to P2 V2. This illustration shows a graph of Boyle's law, where the mass and the temperature remain constant or frozen. As the pressure of the gas increases, the volume of the gas decreases. Now for some calculations involving Boyle's law, where P1 V1 is equal to P2 times V2. If a gas at 25 degrees Celsius occupies 3.60 liters at a pressure of 1 atmosphere, 1 atm, what will be its volume at a pressure of 2.50 atm? Temperature is constant, so it is not important in calculating the volume in this particular case. So from the data we write, P1 is equal to 1 atm. V1 is equal to 3.60 liters. P2 is equal to 2.5 atm. And V2 is unknown. From the solution we write the following. 1 atm times 3.60 liters, where 1 atm is P1, V1 is 3.60 liters, and this is equal to 2.50 atm, which represents P2, and then this is multiplied times V2. To solve for V2, we write the following. 3.60 liters times 1 atm divided by 2.50 atm. The atmospheres will cancel, and the answer is 1.44 liters. This represents the numerical setup for calculating V2 in this particular case. Next, a gas occupies 11.2 liters at 0.860 atm. What is the pressure if the volume becomes 15.0 liters? From the data we write, P1 is equal to 0.860 ATM. V1 is equal to 11.2 liters. P2 is unknown, and V2 is equal to 15 liters. So in the solution we write 0.860 ATM times 11.2 liters. This is equal to an unknown pressure times 15 liters. To solve for the pressure, we write P2 is equal to 0.860 ATM times 11.2 liters divided by 15.0 liters. The liters will cancel, and the answer is 0.642 ATM. Ammonia gas occupies a volume of 450 milliliters. This means that the volume is exactly 450 milliliters at a pressure of 720 ATM, which means that the pressure is exactly 720 ATM. What volume will it occupy at standard pressure, or STP? Standard temperature is 0 degrees Celsius or 273 K. Standard pressure is 1 ATM or 101.3 kPa. In this case, P2 is equal to 1 ATM. So in the data we may write P1 is equal to 720 ATM. V1 is equal to 450 milliliters. P2 is equal to 1.0 ATM, and V2 is unknown. So in the solution we write the following. 720 ATM times 450 milliliters is equal to 1.0 ATM times V2. V2 is equal to 450 milliliters times 720 ATM divided by 1 ATM. ATMs will cancel, and the answer is 324,000 milliliters. This concludes my lesson on Boyles Law. Hopefully this video has been helpful. Thanks for watching.